There you go.
Now we can start the broadcast. Hello from Left Brain Games in beautiful Torrington, Connecticut. Welcome to the AMA for Dynamakr and CircuitBot and everything else that has come out of this program. Our project, this is part of the CSFV project, which is crowdsourced formal verification. We are, our portion of the project is to create a game that connects up with a system for verifying software, and we'll get into that later, what that is, that people who have no training and anything to do with formal verification can play the game and be providing useful information that helps us keep software safe. My name is Andrew Keplinger, president of Left Brain Games, and Greg Izzo here.
Hello, yes, Greg, right here.
Technology, yes.
We have hands. There they are.
Well, we allowed them to have hands today. Who knows what will happen? Our project
go well.
This is going to go great. Our project was funded by DARPA, but we don't speak for DARPA or the Department of Defense. We just make games, and we're just part of this project. And we're going to tell you a little bit about what the process was like to go through and create actually 2 games and an application based upon this technology and research and the trials and tribulations and all that fun stuff. We're going to try to answer some questions that were sent to us as part of this project, and be able to, maybe you find some useful information here if I don't ramble constantly. So the first part of this project, I guess, is kind of like, how did it happen? What allowed this to come into being? And,
how did it happen?
We were approached by another company, Kestrel Technology, who they make verification software. I'm shaking the world. So they create verification software, and they needed a partner to go into this who would help them take what is pretty dry, scientific, logic-based stuff and turn that into a game. And fortunately, the name of our company is Left Brain Games. The concept is we take logical things and turn them into games. So that seemed like a good kind of fit. Left Brain Games, we've been making games for a long, long time now, over 10 years under this name. And previous to that, Greg and I have been working together for a long time. We make games for children, we make games for training purposes, we make games to do a lot of different things. We do games for movies that come out.
Sure.
We do children's educational kind of things. We do stuff. Mobile games now, a lot of mobile games.
We have a lot of technology background, so we can draw on a lot of different platforms and technologies to make games or things that are kind of game-like. So this is a good project to work on. Yeah, it's kind of like we have a set of tools that we can use to do a lot of different things, and then the background of understanding how to teach through software. So that's kind of like, they approached us and said, hey, can you, is this something you can help us with? And we looked into it and said, yeah, this looks like a great opportunity to, try to, it was going to be challenging. We knew that going into it. We knew this is kind of R&D kind of stuff. So it's, it's kind of fun problem solving. And at the same time, you still got to, you actually have to solve the problems, just have fun playing with it. It's not like a Rubik's Cube where you just put it down and be like, I give up. Nope, this is real work. You have to make these things go and make it make sense for people. And that was the goal of the project. DARPA saw this, other projects before this that were crowdsourced, where workers being distributed in a way that average people could do a little bit, and all little bits help to get the job done. So they thought, hey, we've got these verification problem, and there's experts out there, and there's not many of them that do this. So if we could break the problem down and make it into games, then we can get a lot of people to help. Yeah, so that's probably an important part of it. Like, what is software verification? And kind of good way to understand it. It's kind of like I kind of imagine it like if you got a
refurbished piece of equipment, or you got a car that was certified. They stamped it and said, yes, we tested this thing, it's stamped now, and we can certify that this car does not have any defects. So that's kind of the concept of what they want to be able to do with software verification, is to really determine, is this solid? Is this piece of software solid? Does it have any problems with it, or can you really just say this is good stuff, good software? And so they have a lot of different criteria that they look at for things that could go wrong, and we kind of dealt with one angle of that technology through the verification that the Kestrel technology provides. And so I guess what we wound up doing was that this is known kind of from the very beginning of the project, that there was some software that would run. There's a verification tool that would run. It would produce data files of some kind where there's unknown information, and that we would get that translated into a form that we then use inside of the game. The players, by playing the game, would actually provide the missing information, and that would get fed back into the original verification software, and they would say, great, now I've got the information I need in order to know for certain that certain types of problems will never happen. I have everything here, and this proves, and they can actually create a proof, with the information provided that basically says, yep, we can know that these kinds of problems won't happen, check them off the list, or that there's, the potential that they could happen, but the real goal here is to kind of just to be able to say, nope, this is solid code. So that's kind of like what verification is. So when we started this project out, right at the very beginning, there was kind of, we were going at it from a different angle, and not us. I mean, we were, Texas Tech, who is kind of a go-between between Kestrel technology and us. That Texas Tech's job was to write the kind of conversion stuff. Their system talks to Kestrel and it talks to us, and it's kind of a bridge between the two.
Yeah, the game model, they designed the thing that draws them both together.
So initially, I don't know if you want to try to bring up some of the images of what we were working on initially. The name of the project, of course, is, everybody wonders, CircuitBot, what does that mean? What does that have to do with things? And the initial concept that we were looking at was something that seemed a lot closer to kind of a circuit board, where we were imagining, let's see, is that the screen that's coming? Okay, there it is. That's it. So we were imagining, and we were looking at the kind of information we were getting coming in was saying that there was going to be certain kind of statements of truth that we were going to be working with, and that we had to find a way to have essentially everything that was said to be true, like these little statements, I guess.
Kind of like a if-then kind of things, proving if you follow the logic through the circuit that.
Can you make it bigger, just so we can see some of there's some stuff covered up there, but
let's just see if I can do that. It can be done.
Oh, there you go. See. All right. So anyway, so this was our initial kind of, when we were coming up, and we were going back and forth with Kestrel and Texas Tech, and so we were thinking that everything was going to be based on this. This is what the game would look like. That there would be greater than and less than signs, and we would be comparing stuff. And what we discovered was that was going to be a lot more technical, and they didn't really want to go in this direction eventually. But we let's see, just bring up some of the other images.
Yes. So we thought it was a logic thing, and we were going to have the game, the person playing the game, kind of control the flow of these. You can see down the toward the bottom are the CircuitBot robots, these spider robots.
And they're traveling to these various machines, and every time they pass through a machine, some kind of logical operation took place. So this is all kind of our thinking based upon what we knew at the very beginning of the project.
Right.
And we produced a few variations on this. Some of the video in there, like some of those. Let's play the video over there.
Yeah. Oh, hold on, people. It's just a technology problem here. So we rendered the models of these things and rendered it, and you're seeing kind of the prototype of what gameplay would be like. Robots are released and they follow these logical flow lines, and based on values they carry and their interaction with the machines, the states would change. And the goal was to get all of these robots to deliver their payloads to the end, to get from one place to the other, and you're controlling what happens. And
then you can make decisions along the way about whether to activate or deactivate some of the machines. Anyway, so this is kind of really preliminary thinking on our part, if you maximize that. Okay.
Nope.
It's not it. Thank you, Microsoft.
Sure.
Let's start that up again. Hit that maximize button.
Oh.
There we go. So then the idea was that you'd be solving these individual, like each board would be a puzzle, and then you would solve it. And that was kind of initial thinking. And in the end, they kind of started looking at it from a different angle. But we're going to pull up the next folder, I think.
Okay, sure. Yeah. So
then we realized that it would be kind of boring if we played in this world and all we ever saw was circuit rooms. And so we started developing this idea that each room could actually be kind of different. And that, so we started coming up with kind of this Looney Tune concept. It's not really Looney Tunes, but this idea that each place, so there'd be an ocean theme, a picnic theme, and then these insects that were traveling around would actually be traveling to little kind of Acme lab kind of devices that would do various things. And the things that they did were actually related to the kind of logical operation that was happening. So there would be situations where something would create something else in the world, or let's see, what's this one? That one's tiny. That was a robot just going through a simple logical device underwater. There was going to be kind of a trap, a kind of crab trap. Sometimes they get caught, sometimes they wouldn't. And we developed out some of these things, and then we got to the point. Oh, let's see, this is probably a good example, actually. Talking about some of the logic that was happening and what we were thinking early on. But then we kind of changed direction. And this is a few months into the project. And the realization, kind of analyzing our approach, was that having things happen at discrete times was we had this list of kind of truths that were applied, and all of these truths we were thinking would be sequentially applied, that this is true, and then this, and then this, and then this. And then it turned out that they all need to be simultaneously true. So you can't have a situation where any of them are false. All these things have to be true. And what happens is when they get activated, they create these kind of connections. So we were running around ideas and coming up with, let's see, where is those links down here? And what we came up with,
turn the screen sharing off. It's us. There we go.
Hi, hello. There we go. It's loading that. Okay.
You can't see it in the home audience, but we're going to bring it up on the end.
Okay, yeah. How do you switch? Oh, you switch.
Quick. Hit the switch button. Screen 2, share. There we go.
So we kind of changed our angle of doing this once we realized that things were going to have to be kind of simultaneous. So we wanted that we needed to have the ability for the player to see all the important pieces of information that they need to know. So this is a very simple example where along the back, oops, what did you do?
I clicked on something.
Okay. Oh, okay, yeah, it zooms in on when it does that. So this is a very simple technology test. We built a prototype really fast, taking the information that we had in the most recent versions of things. And so along the back here are 3 little kind of Acme machines that actually look like, what are those things called?
The carnival, the strongman, ring the bell and win a prize.
Ring the bell thing. So each time one of those would get activated in the final game, some kind of fact would be generated, and that would cause new connections to be created between these boxes. And so that, this is a really rough, like, let's see if this idea is a good idea. So then what's shown here is that if the next rule is applied, then these new red pieces of information, they really refer to as facts. The facts are that there's new connections between parts of a computer program that's being verified. So each time we hit the connect button, it demonstrates the new connections that will be created. And these are the connections that need to be fed back into the verification tools. So as the player is playing, they're creating these new connections. And part of the purpose early on was saying, okay, well, what can the player do with this information? And this is kind of a challenge of what we were tasked to do was, how do we turn this into a game? The only way to turn it into the game is to look at the information and to say, what does the player need to know? What don't they need to know? And how can we expose all that information in a way that isn't
boring?
That you don't have to get out a textbook and read all the stuff to understand the basics of this kind of crazy logic. What kind of logic was that? It was I can't remember, there was a word for it, but we got past that a long time ago. Okay, so let's back out of that.
It's going back. The speed of the internet. We're going back, people. Okay, there
we're traveling at the speed of the internet.
Okay.
That link was no good, huh? So then we translated that idea and we said, well, first of all, we knew that there was going to be loads and loads of data coming in, and that we wouldn't have a lot of control over whether the problems being presented to the player were going to be extremely complex or very, very simple, whether they're going to be big or very small, because we were dealing with kind of little subsets of test data and not the real actual converted, this is output from the verification software. We had to work with some smaller things and then come up with a system that would basically allow us to create the games and have the games be,
dynamic.
Well, yeah. I mean, we want people to come back and continue to replay. And we didn't know that the actual actions of solving what needs to be solved was going to be interesting enough. So we wanted to, we wanted to come up with a system that would actually, so we separated. We said, okay, well, let's create some kind of basic game framework to hang everything off of, that we know is the kind of game that somebody would return to and replay. And then have, as a part of the gameplay, the actual work that we wanted to do. And then we could say that this could be, the actual action could be not as fun, or if we couldn't control exactly what was going to happen in there in terms of how fun it would be, that we could try to find a way to drive the player to gameplay by creating an overarching game that will be attractive to certain types of players. So that the kind of approach that we were going with was a kind of made-up space program based upon going out and harvesting asteroids for fuel, and then using that to build an expanding, a series of missions, and so that's kind of how CircuitBot was born. The idea was that every time you wanted to build anything, solar panels or a fuel factory or anything in the game, you would have to play one of the mini games. The mini game would be you actually doing the work that we needed done,
right.
And that in order to complete a mission, you would have to do a certain number of these submissions. And so we would know that if somebody was interested in this concept and wanted to get all the way to the moons of Jupiter, that they would have to go and play 50 of these missions, and in the process they would provide that much information for us. So that's how we came up with CircuitBot.
And it was pretty successful. The outer game, the resource management game, was successful. People liked that part. The response we got was that I like this. I like visiting all the planets and setting up my mining facilities and my fuel factories.
Do I get that to go back to us?
Yes. And but the one part that we struggled with was that part where they did the work. It was difficult for us. Again, these games, all the teams had the same issue where gamifying the work was not something simple, and that took explanation and took tutorials, and start getting into learn the fact that people need to spend time to understand what they have to do in order to do it well. And so we kind of added some automation to it so people could get through it and do the work for us. But that was the biggest challenge, was gamifying the hard work enough so that people would not be turned off by the thinking part, learning part, and it takes too long to understand it, and they could just get on with the game. So screenshots of the actual.
So this is actually when we were planning out what we were going to make and proposing everything. so the concept here was that you would do a series of missions, and each one of the missions would be broken down into a series of steps. So you pick something, you're going to launch something to an asteroid, or you know, in this case, this is a picker. You pick what destination you wanted to go to, and then you'd have a series of things you need to build. And each time you wanted to build one of those things, you played a mini game that related to that. And some of the stuff was proposed concepts that we then later on streamlined some of the things. And as we were building it, we were realizing, okay, we want to make various elements. These are a lot of the things that you could build inside the world. Kind of let your imagination go there. We made 3D models of the planets. We also made models of what the surfaces could look like. And then in the game, there's a series of robots that would land, and these robots, we demonstrated the connections between the robots. And these connections are the facts as they were generated. And along the side of the screen here, these are the actual truths, if you can imagine that way. These are certain facts, say things like this one object points to all of the objects this other object points to, and then that truth, when it's applied to the set of data, creates more links. And so these are kind of preliminary images from developing the game. And then as we got into the game, this is more of what everything wound up looking like at a certain point. And so this is a refined version of what we showed a minute ago, describing more and showing that now you're dealing with money and robots, and the CircuitBot concept turned into actually being the robots forming a circuit. When they were all connected together, they could then automate the fabrication process for building propulsion and solar arrays. And then there was a lot of stuff we tried along the way, and we kind of added things to it, removed things, did some usability testing, tried to get an idea of what aspects of it people like and what they were confused by. There was a lot of usability testing for that. And so we wound up, refining from this point into the actual final version of the game. I think these are some more preliminary. No, this is more preliminary artwork we had put together. Just kind of showing like a very early version, and we simplified these commands that appeared on the side of the screen that are supposed to be commanding the robots, telling them what to do. We'd simplified those and simplified other aspects of the game. We wanted to try to make some gameplay pieces as interesting as possible. So
we launched it. All the games went live in December 2013.
Yeah.
We got a lot of people checking it out. What really helped was some of the news coverage and articles about the VeriGames project. And so we ran that for a while. All the teams ran their games for a while. And in the spring, we started drawing some conclusions about it. And I think one of the main conclusions was that we weren't going to get the crowd of Angry Bird players playing in the lunch in the checkout line of the store. These people who come to play these games are more interested in science. So the next phase of the project was decided that we were going to target those people who had more interest in the science behind verification, more technical likings. So we took a different approach for our next phase game, which we named Dynamo.
So I guess we should clarify that the plan was to actually have two phases in the project. Phase one was to kind of get some things out there and get feedback on them, and then to refine our approach for a phase two. And for phase two, we could have continued with the original game, or we could propose a new game. And we went through the approach of proposing a new game, mostly because we wanted to change the way we were looking at the data. The way we were treating it before, that there would be a set of these truths that would be, that would form one mission. To build solar panels, you just have to make sure that all of these things connect together inside this one piece of this larger program that we're verifying. In the case of what we wound up calling originally Dynamo, and then just to be sure we didn't run afoul of anybody's copyrights, we changed the name to Dynamakr. the concept was that instead of dealing with one set of data at a time, that we could actually deal with a large number of them at the same time and solve them all together, and submit that information to the server. And so we could, in 5 minutes time in CircuitBot, where somebody might have played 2 missions or 2 parts of a mission, we might have actually done 10 times as much work. So that was part of the goal there, was to try to get more efficiency out of the players, get them to be producing more output for us. Which ones do you think you should?
I was just looking for. We had some earlier concepts, but these slides here kind of show it.
So the concept of the dynamo was, what we changed our methodology was that in the original CircuitBot, we figured that the player might spend 80% of their time playing the larger game, and then they would go in and spend 20% of the time playing the smaller game. And we would spend a lot of time trying to build out that over game to make that interesting. We made a lot of moons and asteroids you can go to, a lot of things to discover. And what we discovered was that when we really got into the heart of some of this stuff, is that we needed to go in, we needed to allocate more time to the sciencey back-end logic stuff than we allocated for CircuitBot. That it actually is a bigger part of the whole project, so that we had to go in and for phase 2 for Dynamakr, we wanted the upfront, the main goal to be you are solving these puzzles, and we just wanted to make it graphically cool to look at, cool enough so that somebody would pick up some of the details and go in and delve deeper. And then we wanted there to be a reward game, so we had kind of 2 parts of the project. The first part, we have this dynamo, which what we were describing is kind of a 3D quantum mechanical printing device where you feed in these things called patterns, and the dynamo would take the patterns and use them to print something. So the player would be going in and feeding in patterns and working with the dynamo. I don't know if the mouse shows up in there. I don't know if it does.
I think it does. If you're slow.
Okay. And so all these things would go and be built into a larger design. And so we came up with a lot of kind of simple ways, and what we did initially was we built out a version of the program where we threw in the kitchen sink every control we could possibly imagine, and then we said, now we're going to play with it, and we're going to see which controls actually matter to gameplay and which ones we can remove, or which ones should be automatically applied. And they're just ubiquitous. You just always need to use this one tool. You need this piece of information, or else you can't solve it. So we wound up building out something that had a really large number of options you could select,
and those options really were ways of automating things that we knew in from CircuitBot we wanted to do. You always want to do this in order to get to find the most information. Certain parts we figured out were, these aren't the things the player needs to worry about. Let's automate that task so that they can look at it in a broader way and see more of the data and get a better view and use their natural intuition about how things relate to kind of speed the process forward.
Right. So I mean, part of what we discovered as part of gameplay was that we wanted the player to be able to put together smaller sets of information, bits and pieces of information. We wanted to try to build it into enough gameplay. We're trying to gauge how long would somebody play the first phase of the game before it, and then how often the reward of the second phase of the game would have to be available to balance that, so that somebody feels like there's more to discover. The second phase of the game, we introduce, as you go up in experience in the game, you go up in levels. New types of bad guys get created, become available, and you've got to go in and shoot them. There you go. And so we wound up with Dynamakr. You want to full screen on it?
Right. So we're pulling it off the live server here. It does some loading, but then it presents a really visually interesting screen. Get rid of this bar. Things come in, it talks you through the beginning of steps, but the elements in the screen, I'm just gonna click through the stuff.
So that's the dynamo it's pointing at right now. That's the thing where all the patterns are going to get fed into, and the patterns come out of this pattern generator. It's positioned near the bottom of the screen, and you start out with one pattern already generated. And then you have some scoring elements that appear at the top of the screen. And the idea is that you are going to enhance the energy of patterns to the point that you actually reach a certain threshold at the top of the screen. And once you reach that threshold, either energy, size, or total number of patterns, once you reach that threshold, those patterns can then be fed into the Dynamo, and then you can play the second part of the game, which is you're actually inside the Dynamo.
Right.
So,
so right here, you're interested in finding relationships. Bringing in patterns that are related tends to make you find ways of enhancing the energy easier if patterns are related, or more likely to generate more energy. So it's the idea that things are related is important. That's what these tools up in the upper left do, is looking for different ways that patterns are related to each other. And you're trying to bring in as many that are related so that the energy produced, because they're related, the energy could be greater.
Well, what happens is that when you enhance the energy of one of the patterns, it may generate some pieces of information, some facts, and that those facts can cause related patterns to also produce additional information. So the idea is that if you bring in several together that are connected, that you may generate all of their information together, and the more often you do that, the kind of more efficient you are in terms of solving the entire larger set, the whole design. The whole design might be 5,000 patterns, and you're kind of looking at one piece of it and another piece and some overlapping pieces, and over time, with a lot of players, you will cover the entire design multiple times and be able to reach this point where you've generated all of the information for everything all together. And so then you go into the second part. I think we could probably hit end tutorial and just skip. So the idea is that this is the actual innards. Inside the CircuitBot game, we had all these robots, and the robots were connecting together with lines. And here, the same relationship is actually being described, but it's flying by you. So rather than seeing a group of robots connected by little arrows, you will see them differently. So there's kind of two phases in this part of the game. One is you're flying by all these obstacles, these bad guys. And the other phase, you're actually inside one of the patterns looking at its contents. So here's the bad guy section. And because we were just playing the tutorial, there's only 2 sections. So it'll be, for each pattern you do, there's a section to this, a group of enemies, a wave of bad guys, and a section where you can gain more energy and power up your weapons. So you're alternating between powering up your weapons and shooting bad guys, powering up weapons, shooting bad guys. And then you go back to this game where you put together another set of patterns. And the size of the patterns actually affects how long each instance is. So you're kind of rewarded for doing large patterns and for producing a lot of energy, because the energy is actually something you use in gameplay. So that's how we got to this point. I kind of think that, I know we probably have used up our time for now. So we might have to do another podcast, and I think that this one might deal directly with strategies for Dynamakr. I think that would probably be a good idea to just kind of talk about, how do you play the game and what do each element mean? We can do one of these podcasts where we just point out things and say, this is what I think when we do this. And I think that'd probably be a good idea to do for the next one.
Sure. Be sure to send in any questions to the email. Was it Dynamakr at leftbraingames.com?
And I think we should do the same thing for CircuitBot. Sure. I like this one. This is, by the way, our first podcast ever. So in case you couldn't figure that out, we prepared folders and folders worth of stuff, but
we talked over it all.
So
so we'll see you at the next one. Yeah.
So,
thanks.
Thanks.